All right, so for those of you that were not in the classroom when we corrected our 11.3, here's a quick video where I will go through the key and go through the things that I talked about then. So when we look at number 1, we see that we can factor 15 so that it is 3 times 5 over 3x. And then we can cancel out our 3's and we're left with 5 over x. Now, really what probably most of you did is you saw, hey, I can divide by 3, but here is really the process that you are doing in your head. Our excluded value would be that x cannot equal 0, and I know that in the past I said to just say that EV is x equals 0. Looked into it a little bit more, and when we're stating those excluded values, we want to state those as x is not equal to whatever, or x cannot equal whatever that number is. Now when we look at number 2, we're really breaking 8 up so that it is 2 times 4, and we have 1, 2, 3, 4 p's. Then we have 2 times 1, 2 p's, so we are crossing. We're left with 4, and then we're left with 2 p's. Our excluded value would be that p cannot equal 0. Here they're trying to trick you. Here they're trying to say, hey, we can cross off those m's. But remember, if we have addition, m plus something or m minus something, we cannot cross those out. That is not the same. So this would be in simplest form, and m cannot equal positive 2. Now here, when we're simplifying the rational expression, we are looking, our strategy is to first try to factor the numerator and factor the denominator separately, and then see what we can divide out. So if we factor a 2, we would have that. If we factor a 7, we'd be left with this. Now we can look to cancel. We would have 2 over 7. Our excluded value would be that h cannot equal negative 3. Number 5, the very first thing I would do is write the denominator so that our variable is first. Now when I do that, the numerator and denominator are in the same form, and now I can see that the denominator is just off by a negative. So I would factor a negative out, and now I can see that I've got a 3t minus 8 and a 3t minus 8, so that would leave me with 1 over negative 1, which would just give me negative 1. Now, the tricky part of this one, too, is finding our excluded value, what t cannot equal. We'd look right here to see what would make this 0. Now, I've talked about in the past writing a little equation that is equal to 0 to help you solve this, and I think that this is where that will be very useful, because it's kind of difficult to see that our excluded value is going to be 8/3. So that is where setting up this equation can be helpful. Number 6 is very similar to number 4. We would factor an 8b to the third. The denominator, we would factor a 10b squared. Now we can look to cancel. And then we see that we can divide both the numerator and denominator still by a 2b squared. So that would leave me with 4b over 5. Number 7, I'd rewrite the numerator first, just like in number 5. Now, in the numerator, I see that z is negative. We don't like that, so I'm going to factor out a negative 1. And then next, I'm going to factor what's right here. This would be what can we multiply to get a negative 1, add to get 0. So really, our numerator would be this right here, z minus 1, z plus 1. It'd be that plus minus trick. Our denominator, then, we think about what can we multiply to get negative 2 and add to get positive 1. So we would have z plus 2, z minus 1. Now we see, now that everything's factored out, we see that we can cancel a z minus 1. And then technically, to write this back in simplest form, we would distribute that -1 back into the z and the positive 1. So really our simplest form would look like this. And then our excluded values would be that z cannot equal, and we have to look back at the original, -2 and +1. Number 8, it says, is this in simplest form? And it wants you to explain. Now, some people had said that, hey, it's not in simplest form because these should be distributed. I totally get where you're coming from. What it means by simplest form here is really it's saying, can we factor anything else out? In this case, this would be in simplest form because we cannot factor anything else out. If you remember what our definition of simplest form was, it said that the only common factor that the numerator and denominator have is 1. So you would say, yes, this is in simplest form because the only common factor, or the greatest common factor that's left, is 1. Last couple. These area problems seem like, or perimeter and area problems seem like they're really tricky, but they're not as bad as what you would think. They're really telling you the directions to find the perimeter and put it over the area, and then to give your excluded values. So remember, perimeter is adding all sides. So number 9, if we add up all the sides, we have 1, 2, 3, 4, 7 x's. So that would give me 28x. Then to find my area, it's base times height. So 7x times 7x would give me 49x squared. To simplify that, I can divide each by 7x, and that would give me a 4 over 7x. My excluded value would be that x cannot equal 0. Now number 10 was a little bit more difficult because we have this x plus 4. This side would also be x plus 4. This side would be 6x. So when we add this and this, we would get 12x. When we add this and this, we would have x plus x, so that would be 2x, and 4 plus 4 would give me 8. So our perimeter would be 14x plus 8. Our area, then, would be multiplying these. So that would give me 6x times x plus 4. So I would need to distribute. And it's very important that you distribute that 6x to both the x and the 4. That would give me 6x squared plus 24x. So my perimeter over my area would look just like this. Now I look to factor. I would factor a 2 out of the numerator. I'm going to go kind of down here. So 2 would give me 7x plus 4. And then I can factor a 6x out of the denominator. Now this doesn't show me right away anything that I can cancel. It does show me that I can divide both the numerator and denominator by 2. And now a lot of people here were like, Mr. Lehman, why did we even factor in this step when all we did was divide by 2? I could have seen that right here. Well, remember, we still need to find our excluded values. So finding our excluded values is really easy to do when we have this in factored form. We see that x could not equal 0 or -4. So that's why that factoring can be really, really helpful. Really, we would want to distribute this back into the parentheses to write it all the way in simplified form. So that's what those perimeter and area ones would look like. Now, this last one, write a rational expression whose excluded values are 4 and -1. We know that in order to get our excluded values, we look at the denominator of our fraction. So it doesn't matter what's going on the top. You could have 2, you could have x to the 3rd power, you could have 15x. It doesn't matter what you have in the numerator. But our denominator, in order to get these excluded values, we would have to put something that would make it so that when we plug 4 in, we get 0. When we plug -1 in, that we would get 0. So again, it doesn't matter what you have in the numerator. You can have whatever number you want. But in our denominator, we've got to have these terms to make it so that our excluded values would be 4 and -1.